Hello everyone, welcome to Grade 12 Physics AP, Mastering Free Body Diagram in Minutes. In this video, I'm going to talk about the different forces that you would see in your free body diagram problems in your exam. So the force that I'm going to first talk about is the normal force, and it's often a force in which students neglect while drawing their free body diagrams. So what is a normal force? When an object lies on a surface, the force that counters the gravitational force so that the object stays on top of the surface and does not continue to fall downwards is called a normal force. Note that the normal force is the force that acts perpendicular to the surface where the object rests. And depending the angle of the surface, the normal force may not always equal to the weight or the gravitational force imposed on the object. Tension. Tension is a force applied to the object via string, rope, or spring. So, for example, an object being suspended from the ceiling using a rope, you could see the free body diagram to be like this. T is usually representing the tension. Sometimes it can also be just with the letter F. It doesn't really matter because it's just a variable. But usually in problems, people would just state that tension forces would be represented by the letter T. Friction. Friction is a force that acts parallel to two surfaces in contact. It applies when an object is moving on a surface and the direction of the frictional force would be opposite to that of the motion. Friction force is the product of the coefficient of friction and the normal force. And the formula is the frictional force equals to mu and then times the normal force, where mu is the coefficient of friction and the value will be between 0 and 1. Torque is something different, but it might not even be on your exam, but it's actually a very good to know thing. So what it is it occurs when a force causes the object to rotate. The formula for torque is given as where torque equals to force times a distance, where force is the force being applied on in the object to cause it to rotate, and the distance is the distance of the force from the fulcrum, and the fulcrum is the point from which the object rotates. So in the diagram that you can see here, the force would be applied at the end of the round stick, and the distance would be the separation between where the force is applied and where the fulcrum is, or the central point of which the stick will rotate in which here we're represented by a blue dot. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.